Hello, hello everyone. Welcome back to the session on Agentic AI. Since we had decided in our last session that we are going back to basics, so we saw how Python works, especially in data manipulation or handling data. So today we will take a look at, before going forward, let's go back and look at some of the AI algorithms that normally we can use. Okay. Going back again, I wanted to discuss about linear regression using Python. So basically, we'll use the same data set that we had used earlier, which is USA housing. Uh, so basically, the data set represents the real estate data where you have income of residents, average area, house age, average area number of rooms, average area number of bedrooms, area, population, price, address, and all those things. Okay. So basically, first we will check out our data or do some or understand our data, and then we will go ahead and create data modeling. Okay. Now, before even going there, so let's import the libraries that we need. So import pandas as pd, and then I also want to import numpy, import numpy as and as np, and then we are good. So basically, in the course, in the due course, I'll also import scikit-learn, but for now we are good. Let's first take a look at the data and then we will understand. Okay. Now, so if I want to check out the data, so basically I can just go ahead and use this. Sorry. Okay. So after importing, so since I have my file in my root location, so I can import it using read underscore CSV, and it's a CSV file, so I can use that. So basically, I'll use USA. I'll call it like I'll call or I'll create a data frame. I'll call it as USA housing, and then I'll use pd dot read underscore CSV. Okay. Now, in this file, I'll basically import the CSV file, or I'll provide the location, which is, sorry, USA underscore housing dot CSV. Okay. So this is the location. Sorry, this is the file name. Okay. If I want to use a location, I can even create another variable with the entire string, and then I can pass that variable read underscore CSV as well. Okay. So that completely depends. Okay. Um, Now, once I'm done, I will save it. Now, if I want to check how the data looks, so I can use, or I'll check first few records. So since, or we can use the head method. So USA housing dot head. Okay, and by default, as we have discussed earlier, it will have top five records, and then if you want more records, you can always pass the values or within this particular method. Okay, so now if I want to execute, okay, sorry, my mistake, so I have not used a print here, so I'll use print of this. Okay, so now we are good. So now if we go ahead and execute, so now this is what we get. So basically, average area income, average area house, average area house age, average area number of rooms, number of bedrooms, average population, price, and the address. Okay. Now, after getting this data, so if I want to do some basic data understanding, or if I want to understand the data, then there are some other functions that are also available as well. So if I want to print info about, sorry, I'll just maintain as it is, and then I want to print some information about this data set or this data frame that I have created. I can create print USA housing dot info. Okay. Now, if I'm using this, and I will get some more information. So I comment out the earlier print, and then I'll save it, and then let me just execute. Let me clear this. Okay, so let's understand the data. So using info, so basically using info method, we can understand or we will have a better understanding of the data frame. So if you can see out of all these parameters or all these columns, so you have 5,000 records which are float for area income, then all these are float values till price, and then address is basically string. So that's why it's called as object. Okay, so it will give also the data types float as six columns are float, and then one column is object. Okay, so total memory usage and all, you will also get that information as well. So now on top of it, if you want to understand a bit more, okay, so you can also use another method. It's called describe. Okay, so okay, so another method that we have created is called describe. Okay, so now within describe, there are many things that you can pass within describe, but yeah, so I'll just leave it blank so that I get everything in. Okay, so all the information that is required, I can get it. So now let me save it and execute. Using describe, this is the information that we get. So basically, for every column, what is the count, mean, standard deviation, minimum value, maximum value, 25 percentile value, 50 percentile value, and 75 percentile value. So you'll get all those information for all the columns that you have. Okay. Next, I want to extract all the columns from that particular data, from that particular data frame. So basically, I can use columns. So I'll use, let's say, housing dot columns. Okay. Now, once I'm using columns, so basically this is more of a property of a data frame. So that's why I don't pass brackets. So basically that's why I mean the objective of using columns is extract, or it is one of the properties of data frame where it extracts a data frame property which is columns. Okay, so if I go ahead and print it out, print. Okay, so this is the output that we get. Okay, now on top of it, like uh, if I want to find out correlation, okay, so how all the columns are dependent on each other, or how the columns are interacting with each other, so I can also do a correlation. So let me also show that. Okay, now I go ahead and execute. Correlation does not, if I understand properly, correlation works with only like another library. So will ignore that. So correlation is also, we will not include correlation here. But yeah, so you can use this particular approach or correlation to find out what is the relationship between the two or the variables or how they are interacting with each other. Okay, so we can also find an alternative to this. At times, what happens if we have text in I mean as one of the text values or object values as one of the columns, normally the dot core this particular method doesn't work. So because it's not expecting any text values, so so basically we have an alternate approach. Either we can delete a particular column, or I mean the address column which is having text values, or else there is another approach which is something like this. So basically I'll create another variable. We'll call it as correlation matrix. So, and then I will use the data frame USA housing dot, okay, this particular method, and within that I will pass an argument which will say numeric only is equal to true. So it means it will only consider the numeric fields, and the non-numeric fields it will ignore. Okay, so now I'll just go ahead and print this correlation matrix variable. Okay, so now you can see the correlation matrix is up. I mean, we are having this correlation matrix. So what does this represent? So basically, this is the interaction of the parameters with each other. Like for example, if you see average area income, with average area income, it will not give us any value. It will just give us one. So similarly, average area house with average area house will just give us one. Okay, so diagonally, if you see in any matrix, if in any correlation matrix, if you are comparing, so basically it will give us a similar value. I mean diagonally, okay, it will give us one. So that doesn't mean anything, because any parameter with itself will not interact. It will interact the same way. Okay, now our concern, or I'll not say concern, it's not the right word. So our target is which are the parameters or which are the values which are interacting most. Okay, so if I want to understand that, so basically our target value is price, right? So we want to target, or we want to identify price, how price is being affected by all the other parameters. So now if we can see, the first parameter or input parameter, average area income, is 0.639734. Okay, so then if we go, then it's 45, then 331742. So out of these values, out of all these values, I can see the maximum interaction of price is with a average area income. It means any slight change in area income, it definitely affects the price. Okay, next, I would say average area house age has the second most effect on price. Third most effect is average area number of, area population has the third most effect, and then average area number of rooms is next, and the least effect that has on price is the number of bedrooms. So people as very, I mean, the price of the house is very vaguely, or out of these parameters, it is the least concern. Like people, I mean, the price of the house will go up or down depending on the number of bedrooms. Okay, so if in the future, what happens once we create a data model, if we are making any change, or once we create the data model, or once we do our create a prediction model, if the accuracy is not correct, then we go for elimination of input parameters. So out of these five parameters, if I would eliminate one of the parameters, then it would be average area number of bedrooms. That would be the first parameter that I would eliminate, and I'll keep the rest of the four parameters to understand or to check if the new data model that I've created is accurate or not, or all the other values that the data model is generating is accurate or not. Okay, so that is one of the ways how we can eliminate the input parameters. So in real life case, so basically I have a target variable and then I have some input variables. I can have 20 to 30 input variables, but at times I may not use I may not use all those input variables in my model equation or in my data predictive model, right? So what I would do, I would rather eliminate some of the values and only then focus on the remaining values to create my model equation. Now, when it comes to model equation, if you have watched my earlier videos, I have already discussed about model equation, where the equation of a straight line where we have I mean, it can be like price is equal to some value 1 times the first parameter, average income, plus then value 2 multiplied by average area house, plus value 3 multiplied by. So basically it may not be a two-dimensional or three-dimensional straight line, but if we are comparing like the 5 dimensions, then within a 5 dimensions it is linear. The structure of all the value or the model equation will be linear, but with respect to 5 dimensions. Okay, now it is not possible to display a 5 dimensional figure, so that's why I'll not be able to display it. But I don't want to confuse you like showing a 2 dimension or 2 or 3 dimension, because at times what happens, you also have more than 3 dimensions. So for example, what I'm showing right now, so basically we have more than I mean, it's almost like not almost. It is 5 dimensions, and then we have price, and then we are creating a straight line and a model equation for the price. Okay. Now, so this is how basically we generate. Now, how do we generate this model equation? Like regression is the process where it helps us to generate the model equation. If you remember, like earlier, I mean, in our initial days or during intermediate, we have a method like if I'm providing you two or three, if you are providing you two matrix, and then from the matrix I can generate the x and y more equation of a straight line, right? So similarly, if there are more dimensions and more data points, regression is the approach which is used to create that straight line or create that model equation. Okay. Now, how accurate is the model equation is something we can always discuss. Now we'll comment this matrix part. Okay, now we will isolate the input and output variables. Okay, now to isolate them, basically I can create two variables x. Okay, here I'll use USA housing, and then I will create I mean, I will extract only those columns that are needed for input variables, and then I will split it, or I will vertically I'll separate them to isolate or make a y variable for price and x variable will be for um, uh, input variables. Okay. So housing. So if you remember, we have done this. Uh, this is your income. 1 second. Let me just bring in this columns. There we go. Um, okay. So what we have: average area income, average area house, numbers, bedroom area, population. 5. Okay, got it. Now, next we'll create another variable for price. So we'll use y housing since it will be a single value or single column, so we can just use the name. Don't have used the extra bracket. Okay, so now we are good. So next, if you want to take a look at how the data is looking, so you can also do that. Like for example, if I can just do a print x dot head and also okay. So now if I just go ahead and execute, okay, so you can see like uh, this is the output. So basically uh, price and then the 5 columns and then we are getting price separately. Okay, so now we are good. So basically we can use these two uh, data frames or data sets to go ahead with our or create our data model, okay, or predictive model. Okay, now, so once we have our data set, so basically whenever we are doing or going for any predictive model, we go for these splits where we split the input variables into two data sets and output variables to two data sets. So basically, if you are looking at housing, USA housing, okay, or if you are looking at X data set and Y data set, so I will split this into 60-40 and even Y as 60-40. Okay. What is the reason? The reason is basically like I want to use some of the data sets for creating the predictive data model, but I also want to use some untouched data which is not being used in the data model to make sure the data model that I have created is good enough. Okay, so that I can find the errors and make sure it is I mean the model that I've created is good enough to use it in production or in real time. Okay, so for that I'll use from scikit-learn model selection. I want to import uh, train test split. Okay, I want to import this train test split, and then I want to use this. So let me show you how to use it. So I'll use x underscore. I'll just create 4 variables. I'm just naming them. You can provide any name you want. Okay, then but in this format. So first one will be train, then test for input, and then train test for output. Okay, and then we have to provide the function train test split, and then we have to provide the mapping. So x is our input, y is our output, and then this is where the test size, this is where we can define what is the value of the test and train sets. Okay, I mean in terms of size. Okay, if I'm providing 0.4, it means I'm dividing the data set into 60-40. Okay, if I'm providing 0.3, it means I'm dividing the data set into 70-30. Okay, so for now I'll go ahead with 70-30, and then we have another argument, random state. So basically it will create shuffling. Okay, so you see it is also been explained. So basically it will shuffle the data set. It will not suppose you have some linear data as in like time series data where every minute something is being monitored, and exactly this one will go up and then this one will go down. So basically random state function is used where it will pick values randomly rather than picking the value in a series. Okay, so now I will use 101. Okay, so basically random state equal to 101 means it's a sequence. From that particular sequence it will pick the value. Okay, now once we are done, again if you want to check the data sets after creating, you are free to do that. So you can use head method and then create or look at individual data frames as well. Okay, but for this one, I will go ahead and I'll start creating the start creating and training the model. Okay, so now from scikit-learn, I'll use linear model, and then I'll import linear regression. Okay, so this is, so I'll import this linear regression. Okay, now once I'm done, so next I will create a variable. So this is the standard process for any most of the predictive models. So I'll create a variable. I'll call it as LM. So I'll use the function linear regression. Okay, so this is my model, and then I'll use this LM to match my training input and output. Okay, so I'll use LM dot fit. So uh, this particular step fit means I'm creating that, or I'm comparing the x and y, and then I'm creating that equation or a straight line. Okay, so now basically, okay, so next I will use linear regression. Okay, think we are good at this step. Okay, so now let's go ahead and execute this one. Okay, so let me save this first. Just give me a second. So here I have made a major mistake. So basically, I'm trying to compare the X train and Y train. So what I have done is basically I'm comparing X test and X train and Y train. So this was a mistake from my end. So because I'm comparing the training sets, right? So training input and training output, then I will test it with training input and test output. So rather than using X train, I'll use Y train. And because there was inconsistency, so that's why. Okay, so now if you see, so the model is trained, so we did not get any error, so we are good to go. Okay, now how do we evaluate if the model that we're using is good enough? Okay, so now if you remember, equation for a straight line is equal to y is equal to mx plus c. So m being the coefficient, and C is basically the intercept, the what we call. Okay, so now if I just want to print out the intercept, because there will be only one intercept and multiple coefficients. Okay, so now if I want to print out the intercept, so it is lm dot intercept. Okay, and then I can add a print on top of it. Print intercept. Okay, now if we execute, so this is the intercept. So basically, our model equation will have this value at the end. Okay, now what about the coefficients? Because we have all these input variables, what will be the coefficient for these values? Okay, now to find the coefficients, again, we can use lm.cof. Okay, so another function. So basically I can use lm, or I can just print coefficient. Okay, okay, so now these are the coefficients. Okay, so it is 10 to the power 1, 10 to the power 5, 10 to the power 5, and accordingly. Okay, so but I want the coefficients to be organized in a better way, like in a table or something. So I can also do that. So basically, rather than directly printing the coefficient, I can create a data frame. So I'll call it as pd dot data frame. Okay, where I can convert these values. This is basically a list, right? So I can convert this array that we have into a data frame. Okay, so now I'll use data frame, and then I'll use ln dot coefficient, and then I want to organize them into columns. So if I can use this x dot columns, okay, which will just give me the columns, and then I can use I can call the column name as coefficients. Okay, so I'll call it as columns, and the value will be okay, coefficient. So the column header will be coefficient. Okay, so next basically I can just go ahead and print the entire thing. So rather than printing it, what I'll do, I'll create a variable, because I would, I might use it at a later stage, right? So I'll use coef data frame. Okay. And next, I'll just go ahead and print coefficient data frame. Okay. So now, if we go ahead and take a look at it, okay. So now you can see we are getting the values, the intercept value, and then the coefficient value. Okay. So now if I want to find out the model equation, so I can create a model equation where price will be equal to 21.62 times average area income plus 165,222.12 times average area house age, and then 405 times average number of rooms, and then we can generate the model equation from these coefficient values. Okay. Now, once we generate the model equation, I mean, it's a manual way of doing it, but if I don't want to do it manually, I can also use other approaches. Okay, so I can use other functions that are available, where I can use those functions to extract the predicted values. Okay, so once I have the model equation, basically I'll put in the x values from the test, and then it will give me, depending on what x values I am putting in, it will give me a y value, right? So that will be my predicted value. And next, what I'll do, I'll compare the predicted value with the actual value. Okay. So now, rather than doing it manually for every row from the test data set or test data frame, that is x test, we can also do it directly using another function. Okay. So like, for example, I'll create a variable. I'll call it as predictions. Okay. And here I will use lm dot predict. Okay. Once I use lm dot predict, I can just, because lm is the model, right? So the data model that we have trained, and then the predict, we are using this predict method. Then we pass in the test data set. Okay. So x underscore test. Okay. So now we're passing the test data set. Okay. Now, once we pass it, we will get the test values. Okay. Now, basically, once we get it, predictions. Okay. So now, basically, we can use these two. So we have this one. Now we already have, so I can before even printing it out, I can compare the two values. Okay, so the predicted values and the actual values. Okay, so now I want to create a data frame so that it compares the predicted values and actual values side by side. So I'll call it as df. Okay, and I'll use the function, sorry, pd dot data frame, and then I'll pass in both the values. Okay. Um, Predictions, and I'll also pass in the actual, sorry, that is y test. Okay. um, and then I'll just go ahead and print. Okay, so now you see I'm able to compare the value side by side. So here, if you see, like, every row, this is the predicted value, this is the actual value. See, it's almost same. So some places it is little different because I cannot get 100% get an 100% accurate result, but it is more or less, it is nearly the same. Okay, now how different, how, I mean, how much is the deviation if I want to find out? So basically I can find out using um, some matrix that we have. Okay, like for example, let me just highlight, comment this part. Okay. Now, if I want to find out mean absolute error, okay, so if I want to get mean absolute error is basically the difference between predicted values and actual values. And then we are going to check or make it like absolute. Okay. So if I want to find out the mean absolute error, so absolute value of this one would be, like for example, print mean absolute error is, okay, so even before doing that, I have to import a function called matrix. Matrix, okay. Matrix. Test and predictions. Okay. And now let me save it and compare. Okay, so this is the number that we're getting. So mean absolute error for y test and predictions, this is the number. Now, whether this number is good enough or this number is not good enough, so that completely depends on the process that you're following. I mean, process as in like from the business side. Okay, so if the business is okay with this number, I mean, there are some use cases where this number might be accurate. Okay, where you are deviating by this number, this value. So like 81,257. So that is fine. Like whenever it's comparing an annual housing price increase or something like that. Okay. But if you are debating by this number, when it comes to maybe something related to healthcare, okay, where you need pinpoint accuracy in those use cases, this is way high. Okay. So basically now you have to start and eliminating some of the other input parameters and then recreate the data model. Okay, so now next another matrix we can use. So we'll call it as mean square error. So this is just basically square of the value. So mean squared error. Okay, and then we'll also generate another one. So we will call it a mean or root mean square error. This one we have to do it using NumPy. So np dot square root of MSC. Okay, mean squared error, and then okay, so we are good now. So now if I go ahead and look at the values, okay, so mean absolute error is this, mean squared error, obviously it will go high because we are squaring it, and uh, then we are finding a square root of this one, so that's why root means squared error. Okay, not square root of this one. So basically like you can search for root mean square error. Okay, so depending on these values we can find whether the model that we have created is accurate or not, and then we can take a call depending on the business needs. Okay, so that's it for this particular session. I hope you liked it. Please do like, subscribe, and follow. That's it from my. Thank you very much.